Okay, in this section we will be solving basic inequalities. So, remember that an inequality is a statement that two expressions are not equal. These are going to be statements that include a greater than, a less than, a greater than or equal to, or a less than or equal to sign. So, make sure that you're familiar with all four of those signs there. The first thing we'll look at is how to determine whether or not something is a solution to an inequality. So, for example 1 here, we see that we have x is greater than or equal to negative 10. So, for each one of these a, b, c, and d, we want to know which ones are a solution. So, we're just plugging that number in where the x is. So, 5 is greater than or equal to negative 10. That is correct. So, that is a solution. Negative 7 greater than or equal to negative 10. That is not correct, so that is not a solution. Negative 17 is greater than or equal to negative 10. Again, not correct. Negative 17 is below negative 10. And last, we have negative 10 is greater than or equal to negative 10. This is a solution because we have the or equal to here. If that was just a greater than sign, then this would be false. But since we have the or equal to sign, negative 10 is equal to negative 10, so this is a solution. That's a very simple example. Another example would be one like number 2, where we have 2x minus 5 is less than 4. So one way that we could solve this is to solve the inequality. But the other thing we can do is plug the numbers in. So 2 times 3 minus 5, that's going to give us 6 minus 5, which is 1. 1 is less than 4, so this is a solution. When we plug in negative 4, we have 2 times negative 4 minus 5. 2 times negative 4 is negative 8 minus 5. And negative 8 minus 5 is going to give us negative 13. Negative 13 is less than 4 as well, so this is a solution. We can try 8. 2 times 8 minus 5 is less than 4. That's going to give us 16 minus 5. And 16 minus 5 is 11. 11 is not less than 4, so 8 is not a solution. And in D, we have 4.5, so we would have 2 times 4.5 minus 5. 2 times 4.5 is 9. 9 minus 5 is 4. 4 less than 4 is what we end up with here. 4 is not less than 4. We do not have an or equal to sign here, so this is not an answer. So out of the 4 possible solutions here, A and B are the only ones that are actually answers to this inequality. Now, of course, there are lots of other numbers that also work here. If we plug in 1, 1 is going to be a solution. This doesn't mean these are the only ones, but 3 and negative 4 are some of the solutions that make this inequality true. Whenever we solve inequalities, we're also going to graph those inequalities. So whenever we're graphing an inequality, there are a few things to remember. The first thing we're going to look at here is we've got a graph, and we need to write the inequality for that graph. Now we can see here that all of the numbers above 2 are shaded. So that tells us that x, or whatever variable you want to use, is greater than 2. The number's larger than 2. Now, because I have this open circle here, I'm just going to use a greater than symbol. When I have an open circle, that is going to be greater than or less than. When I have a closed circle, a filled-in circle, that is going to be greater than or equal to or less than or equal to. So for number 1, we have an open circle. It's just x is greater than 2. For number 2, I have a closed circle, and the numbers below negative 4 are shaded in. So I'm going to have x is less than or equal to negative 4 for that inequality. So with these, it's important to look at whether the circle is open or closed and whether the numbers are above or below. If we scroll down here, these ask us to graph these inequalities. So if we graph number 1, we've got negative 4. When I have you graph these, I like for you to put the number in the middle and then make sure you at least have one number on either side. Now this is a greater than sign, so I'm going to have an open circle. And then I want the numbers where x is greater than negative 4, so the numbers larger than negative 4, the ones to the right, will be shaded. So here's my graph for number 1. Number 2 and 3 are a little bit tricky. Be careful with these because the variable does not come first. Here I had a greater than symbol. The numbers to the right were shaded. Sometimes I tell students to look at this. It almost looks like that is making an arrow that is shaded or that points to the right. However, we can't use that trick whenever we're looking at number 2 because the variable is not first. What I like to do is turn this around and write the variable first. I'm going to put the x here and the 5 here. Now you probably at some point in your career learned about the Pac-Man or the alligator that eats the bigger number. So if the greater than sign here is eating the 5, the alligator is eating the 5, then it still has to be eating the 5 whenever you rewrite this with the variable first. So now we have x is less than or equal to 5. We have to switch that sign. So now whenever we graph that, we can put 5 here in the middle, maybe put 4 below, a 6 above. We're going to use a closed circle because we have an or equal to. And then we're looking here, less than or equal to, so we shade below the 5. Number 3 is similar. I prefer to rewrite this. X is less than negative 2. Notice when you rewrite that, the sign has to flip. So then I will write on my number line, I've got a negative 2. The negative 3 will be down here. The negative 1 here. This is going to be an open circle because my circle is not closed in whenever we have a greater than sign or a less than sign. And so we're going to shade below for the less than here. So those are our graphs. The graphs give us a good picture of what numbers make this inequality true. So let's look at doing this for a few word problems. So in this case, in example 1, it says the maximum class size is 30 students. So if we let x be our class size, the maximum is 30, so you can have 30 students, but you cannot have more. That means our class size is less than or equal to 30. Sometimes that's a little confusing because maximum seems like more, which seems like greater than. But if you see a maximum, that is the upper limit, so it's going to be less than or equal to that upper limit. Example 2 is also a little tricky for students sometimes. If I tell you to bring at least $20 for the field trip, that means you need to bring $20 or more. So if we let x be the amount of money that you bring on this field trip, then x needs to be greater than or equal to 20. This is another one students sometimes have some trouble with because at least sounds like less, which sounds like less than. But if you think of it in terms of an application, if you bring at least $20, it's $20 or more. So let's do some solving some equations. So when we were solving inequalities, we basically solve like we solve a normal equation, except for if you multiply or divide by a negative number, you must flip the inequality sign. So let's look at why we have to do that here. If I divide both sides by negative 2 here, that will give me x on this side. It'll give me negative 4 right here. If I do not flip the inequality sign, if I leave it as it is, then that means x is greater than negative 4. So that means x could be -3, -2, 1, 0, 17, something like that. If I plug those numbers in, like -2, and let's just try -1 is a number that's greater than 0. So -1 is greater than 8. So -2 times -1 gives us 2, but 2 is not greater than 8. So I know this is incorrect. In order to get the correct answers, I have to flip that sign. So if I had x is less than -4, now if I choose a number less than -4, such as -5, -2 times -5 is greater than 8. When I plug that in, I get 10 is greater than 8. That is correct. So I have the correct answer here whenever I do that. So make sure that if you multiply or divide by a negative, you have to flip the inequality sign. So let's do an example here. I still like to draw a line down through my inequality sign because it works a lot like an equal sign. So to solve this equation, it's basically a two-step inequality, not an equation. And we would first subtract 10 from both sides. We get 3x on this side. Whenever that cancels out, we'll have less than or equal to -15. Then we've got to get rid of that 3, so we're going to divide both sides by 3. And here, sometimes students want to flip the sign here, but you're dividing by a positive 3, not a negative. Even though the 15 is negative, we're dividing by a positive number. So we do not flip our sign, and we get x is less than or equal to -5. If we want to graph our answer here, and we do, we will draw our number line and put our values on that number line. We will use a closed circle at 5, and we will shade below because we have x is less than or equal to -5. For our next example, we have 1/3 times 3x minus 5 plus 2/3 is greater than or equal to 2. So here we solve this like a normal equation. 1/3 times 3 is like 1/3 times 3 over 1. That's going to give us 3 over 3, which equals 1. So we get 1x, and then we've got 1/3 times -5. Again, -5 is over 1. That gives us -5/3. So 1x minus 5/3 plus 2/3 is greater than or equal to 2. So if I have -5/3 plus 2/3, thankfully I already have common denominators here. So I know my denominator is going to be 3. -5 plus 2 is -3, which -3 divided by 3 gives us -1. So we finally got rid of our fractions here, so that's kind of a relief. Now at this point, I'm going to get rid of that 1 in front of the x because I don't really have to write it. And I'm going to have -1 because -5/3 plus 2/3 equals -1. And that's greater than or equal to 2. I'm going to add the 1 to both sides, and x is greater than or equal to 3. So we want to graph that. So 2, 3, 4 here. We're going to use a closed circle, and this time we have greater than or equal to 3. So we're going to shade to the right. We have 10 minus x is greater than or equal to 4x plus 25. So there's no like terms that we can combine on either side. So we want to move our variable first. It just makes things a little bit cleaner if we do that. So I'm going to add x to both sides. So over on the left-hand side, I'll be left with a 10 greater than or equal to 5x plus 25. Now I'm trying to get that x by itself. So I need to get rid of the 25 first. I'll subtract 25 from both sides. And that's going to give me -15, which is greater than or equal to 5x. And I'm going to divide by 5. So that will give me -3 is greater than or equal to x. Now I don't like to leave my answer with the x on the right-hand side. So I'm going to rewrite this. X is less than or equal to negative 3. It's more typical to see that X written first. If we graph this, we'll have negative 3, negative 2. I'm sorry, it's on the wrong side there. Negative 4, negative 2. We'll use a closed circle because of that or equal to, and it's less than, so we shade below.